In this video, we're talking about IV dosage calculations. In it, you'll look at what an IV order looks like from a provider. You'll look at there's a little bit of different wording with it than some other orders with it. Well, there are some problems in it to kind of show you how to work through the most common types of IV orders, especially the ones like I talked about in class yesterday, where you just need to know how much more time you have on an IV bag, when is the IV going to run out. Now, while you can't right now, you can't do anything as far as changing out the IV bag or anything like that, you'll still need to know for your patient, okay, the RN's going to do it or the IV certified LPN's going to do it. So I'll need to let them know, the bag is almost out. But you also need to know, looking at the IV bag and to make sure, it says ciprofloxacin, it says normal saline, it says D5W and stuff like that. So it's very important that even though you have this going over the IV dosage calculations, that you do go ahead and you go through all the modules on F.A. Davis and do the test, but also you can practice on it in ATI. And at the end of this video, I showed you how to get to the practice to where you can practice IV calculations in ATI. Okay, so there are some components to an IV order. There's going to be the amount of the solution, there's going to be the type of the solution, and there's going to be the time of administration. An example of the amount is 1,000 milliliters, which are those big bags. The bags will come in 500, 50, 100. They don't come in any bigger really than 1,000 cc's that you're going to have to worry about. The D5W is the type. It's also, you're going to see normal saline. You're going to see normal saline with potassium added to it. You're going to see NS half saline. So you're going to see different types of solutions as far as, what the additives are in them, what it is you're wanting to do with them. So, and it'll say right there on the back. And then the time of administration. When we're looking at time of administration, we're looking at to infuse over 8 hours, 30 minutes, 24 hours. So that's what they mean is they're going to tell you how much they want, what type of solution, and in what time that they want you to infuse it in. Now, IV fluids and medications, they are administered by continuous and intermittent infusion. Continuous IV infusions replace or maintain fluids and electrolytes. And the flows continuously run until it's changed. So that means that's where you walk in and you have the IV bag running and you look at the machine and it says like maybe 75 cc, and it'll be like 75 cc's per hour. So it's just going to run that, and when the bag gets to where it's almost empty, they'll change it back out. There's no stop in the continuous IV for any reason, unless maybe you're going through a CAT scan or an MRI. Then the doctor will need to give you an order for it. So if your patient on the floor has a continuous IV, you cannot stop it for them to get up and walk in the hall. Even if they ask you, can you just stop it and let me get up and walk in the hall? Because the order says continuous, it must run continuously. So that's why it's very important to know about when your IV bag is going to run out, so you can make sure that you can replace the bag without there being any stoppage in the IV flow. Now, intermittent infusions, those are like what we call your IV piggybacks or your secondary. Those are the ones where you see the other bag, like you'll see this with especially your IV antibiotics, where they're a smaller bag, maybe 50 or 100, and it will be running usually continue at the same time as your normal saline's running, and you'll still get your medication with that. So those are basically the second bag that's hanging up that's connected to your machine, and you'll see those when we're on the floor with that. And it also explains this in F.A. Davis. Another thing with intermittent is you might have somebody with what we call a saline lock. That is where they have a IV site, but they don't have anything continuously running to it. So they may not need all the extra fluids anymore. So they have stopped the main IV fluid, and they just need to have like Rocephin or ciprofloxacin or diflucan running, and they get it every 8 hours. Well, it's a short IV, so it might run 30 minutes. So you'll see them flush the IV site. You'll see to make sure that the site is patent. They'll hook up this intermittent infusion, run it for the amount of time it's supposed to run, and then come in, stop it, and flush it to get it out of the IV line. And they won't be connected to an IV pole until the next time with it. So there's two different types of intermittent infusion. And then the third is an IV push. This is where you'll come in and you'll just maybe give IV morphine or IV anti-anxiety medication you'll just do it through the IV hub lock with that. So those are the basics of your IV fluids and the components to an IV order. And the IV order will also tell you, if they want you to like morphine, they'll want you to do it IV push. And those are things that as we get into doing this and doing IV medications and stuff, when you do your IV cert, they'll explain a little bit more on that. Here are 3 examples of what typical IV orders do look like. The first one shows 1,000 milliliters of D5W at 125 mils per hour. What that is saying is he wants a bag of D5W to run at 125 milliliters per hour. There's no stop time. There's no end time. So this is going to be a continuous IV. The next one is 1 liter of D5W every 8 hours. So you're going to look at that and think, a liter, what is a liter? This is why we really stressed you learning your conversion. You need to know that 1 liter is 1,000 mil. So you know that when you go in, you're not going to find a IV bag that says 1 liter. You're going to see an IV bag that says 1,000 milliliters on it. So you'll need to know, 1 liter is 1,000 milliliter, a large bag of IV fluids, and it's going to infuse over 8 hours. And the third one is 3 liters of D5W in 24 hours. What that one means is the patient needs to have 3 liters of D5W in a 24-hour period. So that means you're going to need to know how fast you're going to need to run that IV fluid in on that. So just a review of orders. Sometimes the doctor will order an IV at a certain rate at 125 mils per hour. In that case, that's going to be real easy to do. You're just going to plug it into our machines. Sometimes the doctor will order for a certain number of hours, like we talked about in the previous slide, 1,000 milliliters over 8 hours. In this case, the nurse is going to have to convert the order into to do a little bit of a conversion to do milliliters per hour. So that's kind of what we'll look at a little bit on how to do some different things on this PowerPoint. And like I said, you also get more of the practice in ATI and also by doing the F.A. Davis homework. To determine the number of hours an IV will run. For this formula, you're going to have number of milliliters ordered, like 1,000 milliliters, and you're going to have it over number of milliliters per hour to equal the number of hours to run. So in this one, we're looking at how long is this bag of 500 milliliters of D5.5 normal saline going to run at 125 mils per hour. So what you're going to do is, with the formula here, you've got the numbers of milliliters ordered, which is the 500, and then you need to know the number of milliliters per hour, which the doctor has also put in there, which is 125 mils per hour. So you're going to put that under the 500 and do a basic division. you're going to cross cancel your milliliters, which will leave you the hours on the bottom, and divide 500 by 125, which will give you the 4 hours with it. So like I said, it's just a basic conversion. It's very simple with it. So you know that a 500 bag running at 125 mils per hour is going to run for 4 hours. Now with this one, we're calculating mils per hour an IV will infuse. So this one you're going to look at, the doctor has ordered 1,000 mils of D5W to infuse in 10 hours. So you're going to set it up. You always, the amount you have, the amount known, the amount on hand, whatever, the amount of the IV bag is always going to be on top. And then the hours to run is going to be 10 hours. So you know you're going to set it up to plug into the program of the computer. You know you're going to do 100 mils per hour. Because they're already telling you they want the 1,000 bag of D5W to infuse in a 10-hour period. You just need to know what to set your IV rate at, your IV flow rate at. So here's another problem. Problem number 1, the doctor has ordered 500 mils of IV solution with 25,000 units of heparin. It is to infuse at 1,000 units per hour. Calculate the mils per hour flow rate. So here are some steps to help you walk through the problem. So step 1, you're going to look at this. What are you calculating for? The answer is you're looking at mils per hour. Step 2, what amount of IV solution do you have? You have a 500 mil bag with 25,000 units of heparin. And what amount of time do I have to infuse it in? So 1,000 units per hour. This is kind of a little bit more of a complicated with all this information, but we'll walk through it, so don't worry. So step 3 of this problem, you're going to set up the problem. You're going to put your 500 mils over your 25,000 units, and you see on the other side, you've got the X. You see on the other side of the equation, you've got 1,000 units, and you've got 1 hour. So as with these cross multiplications, remember we're going to cancel out matching units, which means we're going to get rid of the U, which is then going to leave us mils on top and hour on the bottom. So then you're going to just kind of help you you can write this out however you want to. Like I said, this is why it's important for you to do the F.A. Davis and stuff, because it shows you the proportion ratio and the other ways that you learned last semester. So, setting up the problem, you can see it down the neck just below this part we just talked about. You've got 500 mils times 1,000 and 25,000 on the bottom, and 1 hour. We've gotten rid of the U there, so this is kind of what it looks like without the U. Then you're going to get rid of the common denominator, do things to cancel out and do that. Do your math part with that. So then you can see that we have got the problem worked to where now it is down to 500 mil times 1 on the top, 25, and 1 hour on the bottom. So basically, you're going to remember you're going to divide 500 into 25, which will give you 20 mils, which will give you 20 mils per hour. So you would set the infusion to run at 20 mils per hour. Okay, with this slide, it's just explaining to you what the IV flow rate is. The flow rate is a measurement of time, the number of drops that flow per minute into the drip chamber, just how fast. It's basically looking at how fast you're going to get the IV fluids to flow. How many drops are dropping off into the IV chamber. Okay, so infusion pumps do not have a calibrated drop factor. The flow rate depends on the volume of fluid ordered and the time of infusion. IV pumps have made it so much simpler for us. It used to be when I went through nursing school, and all of us instructors went through nursing school, we learned how to do what we call gravity, where there is no IV pump, and you see gravity in surgery because you might need to bolus them a lot of fluid a lot of time. So that we learned how to do our flow rate by counting the number drops of IV solution going into that chamber in a minute. So if you had something that needed to go in at 100 drops per minute, you had it going really fast and you learned how to calculate that. IV pumps have helped immensely. So the formula for that is you just need to know the volume of your IV that you want running in, and the time, and that will give you the flow rate per minute, which is like that one of the problems we did a couple of slides back. So IV pumps have made it simpler, but you still need to have an understanding on how to calculate an IV flow rate, the formula with it, just in case, you know, the IV pumps are down, the power is out, or you're down in surgery or someplace where they want you to do gravity tubing. So, next example, 12,000 milliliter D5W IV is ordered to infuse in 10 hours by infusion pump. Calculate the flow rate in milliliters per hour. So determine your givens. Your volume is 1,200 mils. The time is 10 hours. Since the volume is given in milliliters and the time is given in hours, the flow rate can be calculated in one step using this formula. The volume over time, which will give you the milliliters per hour. So you're going to set it up. You're going to put for your volume or your milliliters, 12,000 milliliters, your time, your 10 hours, and you're going to divide the 12,000 by 10, which will give you 120 mils per hour. Therefore, so you're going to plug in 120 mils per hour on your IV pump. Just as simple as that. I'm sorry, this slide is out of order on your PowerPoint presentation. I didn't realize it until I was doing my voiceover that this slide had not got put in the right spot with it. So when you come across this on here on your voiceover and you don't see it on your PowerPoint, it's down just a few slides on it. It is on here. I apologize. I thought I had it corrected, but apparently I did not. So with this is when we're talking about the IV drip factors, and we're going to work a few problems with it. This is just different size of chambers and stuff like that. So, you know, this is where we're going to get some numbers from to work to calculate what the drip rates are on it. So this is just some information to help you kind of work some of the other problems that are due to follow. Now on this slide you see so 3 different pictures here. You see where it says, the first one says continue flow solution set. That said, if you look at it, you see a big 60, and it says, if you look underneath it, it says 60 drops per mil approximately. The ClearLink system says the same thing, and the primary IV set, it says, you see a little teardrop, raindrop, whatever you want to call it, says 15. It's 15 drops per mil approximately. So this is when we're talking about the size of the chamber in a couple of slides back and stuff. You'll see these on the side of your eye when you're pulling out your primary IV tubing, and you'll see that, you know, we're looking at macro drips, micro drips. We're not really going to get into a whole lot of that, but these are when we're talking about, and we're working, you know, some other problems here shortly. This is where they're getting the numbers, because it'll say on the side of it, this will be a 60 drop per mil approximate. So that means it's got either a smaller hole or a bigger hole. That's all this size is telling you, and it's telling you it's going to flow either faster or slower into your IV drip chamber. So taking a little bit from the previous slide, the nurse has a tubing with a drop factor. Remember what I showed you, you know, it's either going to be like a little raindrop or whatever, the previous slide, where it says 15 drops per mil, 60 drops per mil, or 10 drops per mil. That's what we're looking at. So the nurse has a tubing with a drop factor of 15 drops per mil. What is the flow rate? The doctor has ordered 1,000 liters of D5W every 10 hours. So, you know, looking at this problem, if you happen to see it on a test, especially on your state test, you know, okay, the drop factor, I'm going to need to remember that. We're looking for flow rate. Look down at your order. The doctor has ordered in liters, and in 10, you know, wants 1 liter in 10 every 10 hours. So those are the things that you need to take away from this problem. So with this one, we're going to figure out flow rate. So taking all the information that we had in the previous slide, we're going to plug in the formula. So we're looking for flow rate, which is flow rate equals milliliters times drop factor divided by time in minutes. So you're going to take your 10 hours and convert it to minutes, which means you're going to take, there's 60 minutes in an hour, so you're going to take your 10 hours and multiply it times 60 minutes. You're going to also do another step where the order said 1 liter. You're going to convert your 1 liter into 1,000 milliliters with that. So those are the things that you're going to need to take care of right away as you're plugging it in. So when we're setting up the problem, we know we have 1 liter. We need to convert it to 1,000 milliliters. So go ahead and plug that in. You're going to take your drop factor, your IV tubing drop factor of 15 drops per mil, and then you're going to put it over your 10 times 60 minutes, because remember we're changing our hours to minutes. So when we get rid of, you know, the like units and get that all taken care of, you can go down to the next step where it shows flow rate equals 1,000 times 15. We know that and 15 drops, the GTT is drops, over 10 times 60. So you know that when you take 10 times 60, you're going to get 600. So if you're like me, if you're doing it, then you're going to take the 10 times 60 and put your 600 under your division sign, and you're going to take your 1,000 times your 15, which gives you 15,000. So the next step would be like 15,000 divided by 600, and then that will give you your 25, and then you can bring your drops per minute down with that. So as you're going through this and as you're practicing, you're going to see that if they're wanting you to do like the drop factors and stuff, is going to have tubing with a drop factor of 15 drops per mil, 60 drops per mil, or whatever size that drop per mil factor is that they want you to figure out. So with this one, we have got, the question is, the nurse has a tubing with a drop factor of 15 drops per mil. What is the flow rate? The order is IV D5W at 125 mils per hour. So with this one, we're going to look at number of mils times drop factor over time in minutes. The order doesn't kind of really give you a whole lot, but we'll kind of work through this with what we have. So what we know we have is 125 mils per hour. We're going to convert the hour to minutes. So you're going to put your 125 mils times what your drop factor is, because your drop factor is always going to go on top, which is 15 drops per mil. So you know that when you cross it, you get rid of your milliliters. So then drop it down so you can see a little bit, you know, get rid of the clutter. I'm one for getting rid of the clutter as you work your problem. So then the next step is, you see where it is set up to 125 times 15 over 60, which will give you the drops per minute. Remember, the GTT is drops. The slash per and MIN is minutes. So then 125 times 15 is 1,875 over 60. You're going to divide that, and that is going to give you your drops per minute, which will be 31 drops per minute. So you're going to set your flow, so the flow rate is going to be 31 drops per minute. You won't see too many problems like that, but this is just another example of a problem that you might possibly see. So it's just working with what you have. So here's another one of an IV drip rate. There's no pump. No pump equals rate will be drops per minute, also known as gravity drip. This is the formula that you can use with to figure out drops per minute. You're going to take your milliliters per hour times drop factor. Remember, it's the tubing, 15 drops or whatever you have come up with on that one, equals drops per minute. And remember, you're going to convert your hours to minutes when you're doing this. Okay, examples of calculating drops per minute. This is for like gravity tubing again. So the order states 1,000 milliliters of D5W to infuse in 130 milliliters per hour. The drop factor of the tubing is 20 drops per mil. So the formula is going to be mils per hour times drop factor equals drops per minute over 60 minutes. So what we have looking at the order is our milliliters per hour is 130 mils per hour times the drop factor, which is 20 drops per minute, over 60 minutes. Because we know 60 minutes equals 1 hour. So what you're going to do is you're going to do your multiplication. You're going to get rid of your hour, cross that out. Then you're going to look at your math and you're going to see 130 times 20 equals 2,600 over 60. So then you're going to divide to 2,600 by 60, and that is going to give you 43 drops per minute. So manually you would have to count drops as you watch the clock for 1 minute. So you're going to look at the drop chamber, and every time you're going to have your watch with your second hand, and you're going to have it up there by the drip chamber, and you're going to count 43 drops in 1 minute. Now there's a rolling thing on it that you can either speed up the count or slow it down, slow down the speed of the drop so you get 43 drops per minute. So you're going to work with that until you get 43 drops in 1 minute into that drip chamber with that. You can count for 15 seconds and multiply by 4 to give you the 60 seconds. So if you count and you get that, but it's just sometimes easier to make sure that you have the right rate to count for the full minute with it. Another important thing that you're going to need to know and need to understand is labeling IVs. Every IV must be labeled so any professional can check the fluid infusing is correct, because on it, if you look at it, and I want you to look when you guys are doing clinicals, so next week when you're up on the floor with Lonnie and myself, or down in maternal childhood with Lori Lynn, you guys need to be checking and making sure that they're labeled. Now, a lot of times, if it's just normal saline or just a regular bag of fluid running in, that's not going to be labeled 1,000 cc's of fluid, but especially if they've added like potassium to it. So you need to have that label on it. The IV is going to have, if you look at the medication added over here on this label, it says drug. So if they've added medication like potassium or something, it's going to have the drug it's added, the amount was added. So if it said like 20 milliequivalents of potassium was added to it, it's going to have drug, potassium, then it's going to have amount, 20 milliequivalents, then it's going to have added by, so the nurse is going to put her added by, the date and the time it was done. The label, they also have pre-printed labels. You're going to be sure you can. Some of them will have you go in, you print it off. I know, like at Scott City, we're ready to print IV labels. It automatically prints, what the medication is, the date, the time, when, and all that stuff on there with it. This little one here, you need to check on the IV tubing. This wraps around the IV tubing. The IV set needs to be changed every 72 hours. You're going to have the initial of the RN that done it, the start date and time. It's always important, and discard date and time. So if it has been discarded, if it's been up there for 72 hours or almost 72 hours, you're going to need to know, oh, hey, depending on facility policy, but like I said, you're not IV certified, so you're not going to be changing out IV tubing, but, you need to let the nurse know, hey, the IV tubing needs to be changed because it's been up past 72 hours. So hopefully I have helped you. I hope I have helped you throughout this PowerPoint with just a basic understanding of how to do dosage calculations for IV fluids. We've kind of gone over quickly some things. The biggest thing is knowing what the question is asking for, what it is you're trying to figure out, and what it is you want to figure out. So for a test, it will tell you we want you to figure out drops per, how long is the IV bag going to last, drops per minute. We will the questions on the test are going to help you through it, so you're not going to be looking at it going, what is it they want with it? So what else have you learned? What is the formula for meals per hour? This tells you how to figure out meals per hour. How do you calculate how long an IV will run? And how do you calculate the milliliters per hour to the set of an IV pump, to set the IV pump? Those are the main things with it. This will, like I said, this was just a very generic presentation to help you understand. Your biggest base to help you kind of learn is just repetition, doing the math problems, going to F.A. Davis and going through all the individual modules, and then doing your test, and going to ATI and working in the pharmacology, which I will explain to you how to get to that in the next slide. So practice, practice, practice. If you want some more, I can give you some more. I can give you some worksheets so you can kind of work through. So if you want to do that, let me know, and I can give you some of those to kind of help you practice with them. So log into your ATI website, go to your tutorial, simulation, and quizzes, and you'll see the list of things. So you're going to scroll down until you see dosage calculations, and it'll say either dimensional, desired, over have, or ratio, whichever one you wish to work with, whichever one you're comfortable with, or click in all three of them and practice. Just choose one of them, and then choose, when it opens up, then you're going to scroll down where I have the star where it says parenteral IV medications, and do the exercises. This is where you're going to click on to practice IV medications there. The flow rates and stuff like that. This will help you. This is just another means for you to practice, and it's a good thing for you to come in here and practice with it, because we're going to do the pharmacology and the dosage calculation tests and stuff through here, so you're going to see maybe some of these questions on your ATI test. So this is how you can get to where you need to go to in ATI to do your practice for your parenteral IV medication. As I stated, these are just some examples on how to perform IV calculations for IV fluids. Practice your ATI, practice in the do your homework, do the practice modules in F.A. Davis, do your homework at F.A. Davis, and like I have stated a couple of slides back, if you want some more practice, I do have some worksheets and stuff that I can give you so you can practice. I can give them to you, and I do believe they have the answers on the other side of it. If you need some help, we can, come to not just me, just any of the instructors, and we can help you with figuring out where you are struggling with it and stuff. Don't overthink it. Just remember, with any of the dosage calculations, find the information that the question is asking for.